like an exercise and getting ready. Well, hello, everyone. My name is Stan Kegley. I'm with the City of Troy. I'm the project manager. We're glad you're here this evening. If you're here for the Kidder Ditch Update meeting, you're in the right place. If you're here for the Troy High School Awards Banquet, you're in the wrong place. That's next door. Tonight, our special guests are Strand & Associates. They're an engineering firm out of Cincinnati, Ohio. They're very skilled in studying floodplains, floodway development. They're a civil engineering group. And our special guests tonight are Mr. Chris Rust and Mr. John Lyons, who's speaking to you in a few moments about all the research you see on the boards around you, and they will have a presentation for you. I also want to thank many of you because you got the survey in the mail, and you drew on your little drawings of where you had water in your lawns. We do appreciate that greatly. That gave us a lot of additional information we needed for this study. Also, many of you may have saw last about October, November, you may have seen a man walking through your backyard with a survey rod, actually with a GIS person on behalf of this company, getting GPS data, and they literally walked from the Great Miami River all the way up to DeWeese Road where the Great Kidder Ditch begins, getting information about the flow of the water, the width of the ditch, the condition of the ditch, and so forth. So I don't want to, you're not here to listen to me, you're here to listen to these fine gentlemen. So what I'm going to do is step aside. Just so you know, it's a point of interest, the restrooms are right outside these doors here, right in this corridor, if you need to walk over there at some point in time this evening. And there will be a chance for more discussion and walking and discussing things with these gentlemen when this meeting concludes. There will be a PowerPoint presentation as we get started to give you an update on what we've learned so far. And with that, I will bow out to Mr. Chris Rust.
I appreciate everyone coming out to participate in the discussion tonight. The presentation we have here is an overview of where we are at with the current drainage study. As Stan had mentioned, one of the parts of this drainage study was soliciting feedback from you all several months ago as we got started on the drainage study. The presentation today isn't necessarily a final conclusion on where we're at with the drainage study. It's more of an update on what our initial findings are. And as Stan mentioned, we do welcome your feedback at any point during this presentation, and then afterwards a question and answer session. So the agenda we have today for the meeting, we're going to talk about what the purpose of the drainage study is, what the limits of the study are. We do want to have a discussion about easements along Kidder Ditch. We've got a series of maps here that show some of the easements along the ditch. We did want to provide an update on what the responses were as part of that survey and outreach to you all. We do want to talk about our stormwater modeling efforts, so the boards over here we'll touch upon how we got to the conclusion that we're showing on some of the maps here. Some of the preliminary findings of the drainage study, and then ultimately the next steps as part of the study. So the purpose of the drainage study, we've got pictures of flooding here. Some of these came from the city, some of these came from you all as part of our outreach efforts. It seems like the primary issue that is being dealt with throughout the watershed along the ditch is flooding issues. So some of the pictures here, I believe the picture on the top left is the bridge at Maple Crest Drive, which has been prone to overtopping on several occasions. Picture on the top right, some of the flooding along the streets that happens during severe rainfall events. And then along the ditch itself, the bottom two pictures, as that water comes up in the ditch, how it does extend out into the yards and then recedes after the rainfall event. So the primary focus of our drainage study really is evaluating the flooding conditions along the ditch itself. So the limits of the study, this map went out, I think, as part of the invitation to this meeting that just show the limits of the study. So on the map here, Kidder Ditch flows in a southern direction. Our study went all the way up to DeWeese Road to the north, all the way down to Staunton Road to the south. So the pictures here on this slide show some example photos of what the ditch looks like, both at the upstream end and then as you work your way to the downstream end. So kind of towards the upper reaches of the watershed, it's a very small ditch, but then when you get all the way down towards Staunton Road, much bigger, wider, broad ditch. And along those same lines, just the different types of characteristics of the ditch, you know, as we've done this evaluation and done our site visits here, there's different characteristics of the ditch as you work your way from upstream to downstream. So again, this is towards the downstream end, a much kind of bigger, wide ditch. Some portions of the ditch have a concrete lined bottom that conveys the flow during those smaller events. And then other pictures here that just show some of the vegetation and growth along the ditch. But each of those different segments of the ditch, depending upon that characteristic, does change how much flow goes through the ditch. That's part of the study, was incorporating that information of the ditch itself. So one of the things that was evident, as Stan mentioned, we had a surveyor out in the field collecting a lot of topographic data, cross sections along the ditch throughout the whole limits of the study. Portions of this ditch are extremely flat, as I'm sure you all are aware if you live next to the ditch. But in this particular case, what we're showing here between Market Street and Maple Crest, the elevation of the ditch itself really only drops about 1 foot over about 1,000 feet of length. That amounts to a 0.1% slope. So from an engineering standpoint, when you're talking about a very, very flat slope, it's just a little bit more challenging for that water to be conveyed in the slope, when normally we're looking for something with maybe a 0.5% or a 1% slope to get the flow moving a little bit quicker. So that is a constraint throughout this ditch, is just the flat topography that really sometimes limits the amount of conveyance during some rainfall events. We also took note of all of the bridges and culverts along Kidder Ditch. So within the limits of our study, there are 8 bridges. I would call most of them bridges instead of culverts, but there's 8 specific bridges that we took specific measurements on as part of the study and incorporated into our evaluation. So just pictures, we thought it'd be helpful for everyone to see pictures of these bridges, just in case you're not familiar with how certain portions of this ditch look. But again, kind of working our way up downstream to upstream, Staunton Road at the downstream end, going up to Stony Ridge Avenue, Skylark Drive, and Terry Drive. So as part of our evaluation, as we mentioned, having someone in the field collecting survey data, we took detailed measurements on all of these bridges and accounted for that in our stormwater modeling of the watershed. These tend to be important because, you know, as the flow from the channel comes in, it does get restricted a little bit as it comes into the bridge or underneath the bridge and then expands out. And one thing that was evident in some of these bridges, particularly Maple Crest Drive, just the amount of clearance below the bottom of the bridge and the ditch is pretty small. In some cases it's only 2 or 3 feet, where normally you'd want to see a little bit more kind of depth below the bridge to get more flow through it. So again, taking these measurements in the field and incorporating this into the model, which we'll talk about here shortly, was a key component of our evaluation. So easements along the ditch, one of the things that we did as part of this effort was research existing drainage easements along the ditch. And I understand, obviously, this is kind of a broad map of the watershed, but we have more zoomed-in maps over here that we can take a look at after the presentation that show specific locations of where there's a drainage easement along the ditch. In some cases, that drainage easement in the downstream end is as wide as about 100 feet. In other locations, that easement width is about 40 or 50 feet wide. So I thought it would be important to document the location of the drainage easement, just so everyone is aware that there are easements along the ditch on either side of it. So this is more of a zoomed-in image that shows, some of those easement lines in relation to the ditch itself. In some locations, that easement width is 20 or 30 feet off of a property line. So again, the maximum total width of that easement may be 50 feet in some locations. Interestingly enough, some of the things we did note, though, there are some restrictions within the easements, whether it's sheds, playgrounds, other things like that, that really, are currently within the drainage easement that tend to kind of be in the way when there is drainage coming through the easement, where, some of the language from the easements does restrict any sort of structures or anything like that within the drainage easement. So we did want to mention that as part of this, and again, we've got the maps to show the easement lines, and we can have some site-specific discussions about those easements as well. So one of the key parts of our evaluation was the resident survey. Hopefully everyone in the room received that survey back in, I think, January or February timeframe. We did have some specific questions in that survey that really helped inform our drainage evaluation. We did also include a map of everyone's parcel as part of that for you all to mark up, how high you've ever seen the water get on your specific property, and we've got some more information on that here shortly, and why that was important. So that survey went out to about 170 residents along Kidder Ditch. So again, anyone between Staunton Road all the way up towards DeWeese Road, if you have a parcel or a property that is immediately adjacent to the ditch, you should have gotten a survey as part of this. So that went out to about 170 individual property owners. We did get right around 70 responses back. So, again, thank you everyone who did respond to that, because it was important for our evaluation. Quite frankly, the response was better than what we typically see when we do these types of studies. So I think it's a testament to you all that, you are, engaged in this process. So out of, one of the first questions we had in the survey, have you ever experienced, flooding issues on your property? So of the 70 responses, 47 of the responses said no to that question. 23 of the respondents answered yes to that question. So we've color-coded the map here. Any properties in blue, which kind of are clustered right through here, were the ones that maybe were more apt to respond yes to that question related to flooding issues, and we'll drill down here in a minute. So of those 23, this is kind of more a zoomed-in map of where we saw those responses. The majority of the type of flooding that was acknowledged in that survey was more yard flooding. So in other words, you get a rainfall event, the water comes up from the ditch, extends a little bit beyond maybe the banks of the ditch and gets into your yard, and then after the rainfall event, recedes back into the ditch. However, there were a few respondents that did acknowledge basement-related flooding. So some of those properties there highlighted in orange, and that cluster primarily between Scenic and Cloverdale were where we've received responses of more, primary structure-related flooding that tended to be more kind of groundwater seepage-related as opposed to overland flooding that impacted the house. So the extent of flooding, these are just some example screenshots of those survey results where, very specific information was provided where you show, this is how high we've seen the water get on our property. And that is a very important piece in our evaluation when we calibrate these stormwater models to really understand, what is going on in reality from the responses that we got from the residents. So what we did with that information, more in the graphical format, is take all of that information and create this map that shows, based on the responses, how high have the residents ever seen the water get during any rainfall event. And again, this is a very important piece of information, and we'll get more information here. I'll explain in a little bit more detail here shortly. So the May 2014 rainfall event, this was another critical question on that survey. One of the things that we had heard from the city was, there was this big rainfall event back in 2014, May of 2014. Portions of the interstate had to be shut down because there was so much rain during that rainfall event. You see some quotes here from ODOT, categorizing this as a 1,000-year rainfall event because there was so much rain. So parts of the interstate were shut down, both north and south of the city. So we felt like this was a key question to ask, knowing that this was a pretty significant event. You know, what sort of issues did you experience during that event? Was there any sort of primary structure-related flooding as part of that? One of the pieces of information that we evaluate when we do these studies, you know, we do go back and look at the rainfall data that happened during these rainfall events. So this is you know, obviously kind of a colorful map here, but this is radar data from that particular event back in May of 2014. We do tend to use this data maybe a little bit more frequently than just one single rain gauge that may pick up rainfall at one location, but doesn't necessarily tell you how much rainfall fell over a broad area. So on this map, the black boundary here is the city of Troy boundary. The color coding of the map, basically any areas where you see red or orange on this map, there was anywhere between 5 and 7 inches of rainfall that fell during that event, and basically a 3 to 4 hour period. So you can see very kind of intense part of that rainfall event is essentially cut right through the city, and that's part of the reason some of the interstates had to be closed because of the amount of rainfall. So as it relates to Kidder Ditch, this is the boundary of Kidder Ditch here, and here's the ditch itself. So within the Kidder Ditch watershed, about 4 to 6 inches of rainfall fell during that event in approximately 3 hours. So again, a very intense, short duration event. And when we look at kind of the spectrum of rainfall events, when we evaluate that amount of rainfall and that duration, that event really was kind of off the charts, so to speak. So from an engineering standpoint, we tend to think of things in these rainfall events of a 1-year event or a 10-year event or a 100-year event. I did want to clarify when we make those kind of statements, a 100-year event, sometimes it can get confusing. You may think, well, that's an event that should happen once every 100 years. We look at it more from a probability standpoint. A 100-year event has a 1% chance of happening in any given year. And a 10-year event, for example, has a 10% chance of happening in any given year. So this spectrum here shows rainfall depths for a 3-hour duration. So if we were to categorize something as a 1-year event, you're looking at about 1.4 inches of rain in 3 hours. 25-year event, close to 3 inches of rain in 3 hours. This March 2014 event got well over 4 inches of rain, which is even beyond a 100-year event. So some of the photos we got, and again, this was maybe a combination of photos from the city and photos from you all, looking at that rainfall event. So right now we're kind of near the Market Street Bridge. You see the church upstream from the bridge. There's flooding going on just upstream from the bridge, extending just in front of the church, but no evidence or no documentation of actual flooding of the building itself. Market Street here, you can see how much flow is going on immediately downstream of the bridge. We're not always sure when we get these photos if you're really looking at the maximum peak of when the water got up the highest during the event, but we felt like these were probably pretty close to being, towards that most intense part of the event when we look at how high the water got. So the Maple Crest Drive Bridge in this particular event, obviously it did overtop. So Maple Crest Bridge was the one we showed the picture of where there's only a couple feet of clearance below the bridge. I know we heard a lot of responses related to this particular bridge, and some of you all that live upstream from the bridge, where there tends to be a little bit more frequent blockage of debris. We know the city put in kind of a trash rack structure immediately upstream from the bridge to try to keep that debris from getting collected underneath the bridge. But that does tend to result occasionally in these really intense rainfall events of water overtopping that bridge. And then immediately upstream, again, you can see how high the water gets, adjacent to the properties, just upstream from that bridge during this event. The Terry Drive Bridge and Skylark Drive Bridge, these pictures show the water getting really close to the top of the road, not quite overtopping the road. Some of you all may have some more pictures during this event that show it overtopping the road, but according to the pictures we have here, it got really close to the overtopping the bridge during the event. Stony Ridge Avenue near Market Street, there was flooding in some portions of the street here, maybe several inches to a foot of water on the street itself. Stony Ridge Avenue down at Carriage Drive, flooding out on the street as well. So sometimes this can be a symptom of just too much water in the ditch itself, but sometimes when you see street flooding, and I think we saw this in some of the responses from you all, it can be more of a symptom of just there's too much flow on the street, and the inlets and storm sewers out on the street can't convey that flow fast enough. So it tends to be a little bit of a combination of maybe too much flow in the ditch, but then also too much flow on the street itself has a hard time getting into the storm infrastructure system. So in summary on that particular event in May of 2014, out of the responses we've got from a structural flooding standpoint, 39 of the respondents said no to the question whether or not you had structural flooding, and only 3 responded yes to the question about structural flooding, again, kind of in that scenic court area. So the general outcome we saw from this particular event, a very significant rainfall event, yet not a lot of widespread flooding of houses or structures themselves. So when we talk about these different rainfall events, the industry standard for stormwater management, there's different components of the stormwater conveyance system, whether it's the storm sewers or piping network, the open channel system, detention or retention basins. Those are typically designed and sized according to these different rainfall events. So typically a storm sewer system is designed to convey a 10-year event, and you check it for a 25-year event to make sure there's not widespread flooding. Same thing with an open channel system. Detention and retention basins tend to be designed for bigger, up to 100-year rainfall events. So, you know, this is kind of the industry standard when it comes to sizing and designing these types of stormwater conveyance systems. So, you know, quite frankly, when we get these rainfall events that may exceed a 100-year event, a lot of these conveyance systems weren't really designed to convey anything that large. And it can be challenging to do that because it gets very costly to put in really large storm sewers and really large conveyance systems for those really extreme rainfall events. So other drainage issues, we also had a question on the survey about have you experienced just other drainage issues, and we'll touch upon those here in a minute. But, you know, 54 out of the 70 respondents answered no to the question. 16 respondents answered yes. Some of those comments related to that question were tied towards, you know, maybe some erosion in the ditch on your property, maybe some collection of debris. Once you get a rainfall event, there's some debris coming from the ditch, that drainage subsides in the ditch, but then you're left with some debris on the property itself. Localized street flooding, you know, we showed the pictures of that. And then there were several comments about flood insurance, which we'll touch upon here in a minute as well. So Kidder Ditch stormwater modeling, as part of our evaluation, we do detailed stormwater modeling, which is basically a term we say for the computer program that we use to simulate these rainfall events to try to replicate what we're seeing in the field. So the watershed itself encompasses over 3,000 acres. This map here shows the full extent of the watershed. So the Weiss Road, just for reference, is right here. Staunton Road is down here. Here's Kidder Ditch. So even all of this drainage upstream, you know, encompassing a total area of 3,000 acres, all flows towards Kidder Ditch. So we may say that the extent of our evaluation was towards the Weiss Road. Quite frankly, when we build the stormwater model, we're collecting all of that drainage from that entire 3,000 acres and conveying that runoff down to Kidder Ditch the way it does in reality. So the land use of Kidder Ditch watershed or drainage area, the land use tends to impact how much stormwater runoff gets generated from the watershed. So areas highlighted here in yellow are the agricultural land uses within the watershed. The orange area here represents the residential area, and then the green areas just represent some small areas of wooded area that remain within the watershed. So kind of a predominant mix of residential in the southern portion of the watershed, but a lot of agricultural land use on the northern end of the watershed. Impervious areas tend to be an important component when we do these evaluations from a stormwater modeling standpoint. So impervious areas are anything like rooftops, driveways, sidewalks, roads. Anytime there's new impervious areas implemented or installed, that generates more runoff because you're changing it from more of a kind of an undeveloped landscape area to an impervious area. And in the world of stormwater modeling and stormwater calculations, that generates more stormwater runoff. So within the drainage area of Kidder Ditch, there's about 250 acres of impervious areas throughout the whole drainage area, or about 8% of that 3,000 acres consists of impervious areas. So one of the things that we looked at as part of this evaluation is the development in the past 10 years within the Kidder Ditch watershed. So all these areas highlighted in yellow here, kind of, middle part of the drainage area, still south of all of the agricultural area, but just north of the residential area here, has been developed within the past 10 years. And this represents about 260 acres of newer development within the last 10 years. We did want to acknowledge the city does have stormwater management regulations. There is a stormwater ordinance. It's Chapter 1125 of the city's ordinances, all about stormwater management. And there's very specific requirements within that ordinance that requires any sort of new development or redevelopment to manage their stormwater runoff from a water quality and a water quantity standpoint. And by water quantity, I'm kind of tying that back into those detention or retention basins where, in order to offset all of that new impervious surface that's generating more runoff, you have to implement and construct new detention basins to capture that drainage and release it basically according to what the release rates were prior to the development. So there are specific requirements in the city's ordinances that applied to those newer development areas over the last 10 years. So when we look at these areas, the number of stormwater retention or detention basins connected to those newer development areas, there's about 16 of them kind of sprinkled throughout those newer development areas. So older parts of kind of the developed area of the watershed, all of that would have been developed prior to any sort of stormwater management regulations, but since the inception and the adoption of those stormwater management requirements, anytime there's new development occurring, these types of stormwater management facilities have to be installed. So just some pictures of what these look like, kind of big retention ponds. Some of them are dry detention basins that look dry. They fill up with water during a rainfall event. They're all kind of, designed with these outlet control structures that are, specifically designed to regulate how much flow goes out of the detention facility again, all in the context of trying to minimize the impact downstream. So as part of our evaluation from a stormwater modeling standpoint, we did break the watershed down into these 75 different subcatchments. For each one of these subcatchments, we're incorporating how much impervious area is within that watershed, what are the runoff coefficients, how do those impact the magnitude of peak flow rates in the drainage coming from the watershed, and all of that information gets incorporated into the stormwater models that we use to simulate the flow. So some of the modeling results, and I know some of you have already started looking at some of these maps over here that we've got on the boards. So the images here in the presentation are represented over here with the maps as well. So after the presentation, we can talk through some of the specifics of these. But one of the things that we noticed as part of our evaluation, the FEMA floodplain mapping, the 100-year floodplain that FEMA has previously developed, does appear to extend well beyond kind of the reality that we've heard from the residents, either based on the survey or when we go back and look at that event back in 2014, that was well beyond a 100-year event, where there wasn't a whole lot of structural flooding. What we're seeing in our stormwater model when we run these larger events like the 100-year event, a much smaller footprint of that floodplain. So on all of these maps that follow, this kind of lighter shaded area on the maps is the current FEMA 100-year floodplain, and the darker blue areas on these maps represent kind of where we're currently at with our stormwater modeling for a 100-year event. This isn't exact, it's not a precise science by any means, as these stormwater models are the best tools that we have to try to simulate these rainfall events to predict how high we think the water could get during these larger rainfall events. So, as we cycle through these, and again, I would welcome everyone to come over and look at the boards and we can talk through specific properties, but the general outcome when we look, and we're kind of working our way from upstream to downstream on these maps, and that's how we've got them set up over here. Kind of the left side is upstream, and you work your way downstream. The general conclusion that we're seeing here, initially is that the 100-year floodplain extents appear to be well beyond anything based in reality from what we've seen. So again, here, just some imagery. This is Skylark, Longwood, Mystic, Stony Ridge here. Pretty dramatic potential changes where, again, the FEMA floodplain maps show a pretty broad area within the 100-year floodplain, and according to where we're at with our stormwater models, we're showing a much smaller footprint of that. And this is kind of towards the downstream end as well. So Staunton Road would be kind of down here, just off the map. So more recently, there was a rainfall event back in March of 2021. When we looked at the rainfall data corresponding with that event, it did correlate to about a 25-year rainfall event. So as during our evaluation, we just happened to get a rainfall event that kind of registered on the scale, nowhere nearly as close to the magnitude of the event back in May of 2014, but still a pretty sizable rainfall event. A 25-year event is a fairly significant rainfall event. Looking at the pictures of that rainfall event here, and again, this is, Market Street, working our way down to Stony Ridge Drive. You can see the flow is generally contained within the ditch. As you kind of look at Market Street, just upstream of Market Street. Maple Crest Drive, again, it got really close to Maple Crest Drive, but didn't overtop in that particular 25-year event. Skylark and Terry Drive, it's, and even Stony Ridge, the flow is still contained within the kind of the concrete areas bound by that ditch. So a pretty telling, storm event here, where for a 25-year event, maybe we would have expected to see a little bit more flooding, but according to those photos, we just didn't see a whole lot of it. So the preliminary findings of our drainage study, primary structure flooding within the Kidder Ditch study area during extreme rainfall events appears to be limited to a few properties. So again, going back and talking through those survey results, there were a few properties that acknowledged structure flooding, but the majority of those seem to be kind of groundwater seepage issues. When the water gets up to a certain elevation in the ditch, maybe there's some basement flooding that's seeping through the groundwater, causing some issues in the basements. There may have been one or two circumstances where, the water got up high enough to spill over into a window well next to the house and got into the basement. So maybe a few circumstances like that, but not a kind of broad primary structure resident flooding. The FEMA floodplain mapping appears to extend well beyond any previously documented flooding, and I say including that May of 2014 rainfall event. Again, very broad floodplain mapping done by FEMA years and years ago, and kind of the current reality that we see here is the limits of that floodplain appear to extend well beyond anything that's been documented in the past. Maintenance activities and responsibilities within the drainage easement need to be more clearly conveyed to the residents. As part of this effort, this is kind of a public education outreach effort as well. Just making sure everyone is aware that there are drainage easements along the ditch. We're going to be working with the city to maybe develop some specific documentation of things that you could be doing within that drainage easement to keep it open so the water can be conveyed a little bit better within the ditch itself. And then enhanced maintenance and inspection activities by the city at the bridge and outfall locations should reduce potential for debris buildup, which impacts the capacity of the system. So near some of those bridges, there does tend to be a little bit of deposition of debris and sediment that gets deposited. If the city cleans that out a little bit more frequently, that would maintain the flow a little bit better through the ditches or through the bridges. Those tend to be those critical points where the flow kind of contracts underneath the ditch. So maybe some enhanced maintenance around those, and then the storm sewer outfalls themselves. I don't know if any of you live where there's maybe a small storm sewer outfall that discharges into the ditch. Sometimes there tends to be a little bit of deposition, build up around those outfalls, and that can restrict some of the flow coming from the pipes themselves from out in the streets into the ditch. So the next steps as part of this drainage study, obtain feedback from you all on the preliminary findings. We do want to continue to get your feedback at the meeting here today after this presentation. We do want to hear your feedback too on the FEMA floodplain mapping. We can't make any guarantees based on these results that FEMA will agree to very broad floodplain mapping changes. but we feel like we're building enough evidence and supporting documentation here that, you know, we could consider going down that path of modifying the FEMA floodplain mapping based on the drainage study that we're working on. The city does intend to install a new detention basin near Finsbury Lane. Christie, I don't know if you want to chime in on the kind of the timing of that and what that's about.
City council at their last meeting authorized the payment for that project to be done as part of the new clubhouse that is being built there on Halifax. So I would anticipate, honestly, within the next month, that we will see the contractor out there starting to work.
Okay, thank you. And then ultimately, we plan to finalize the drainage study based on the community's feedback. So with that, we will open it up for questions. We did include Stan's contact information on the slide here for, you know, any other follow-up questions beyond the discussion here tonight. But we can either do a question and answer here now, or if we want to break off and look at the boards, John and I are available here for however long we need to answer any questions you may have. Sure.
First of all, I want to thank you for that great presentation.
Thank you.
It really was educational. I do want to get Stan's phone number, though, because the next time before this 1,000-year rain hits or the 100-year rain, we've been there 23 years. I want to call him, have him come out and take some pictures, because we've been there, my wife and I have been there 23 years, and many times it has come up into our yard, close, not the house yet, but many more times than you can imagine. Forget ODOT's 1,000 years, that representative come here and talk to me in 100 years. But we've been there 23 years with the second house off of North Market on Stony River. And believe me, we've had many times that it's come up and done some really good damage, not if it's plowing, but